Okay, so we're moving on to assignment number 5 on this unit 4, and this is the basics of probability. And so in 4.5, we're going to be talking about conditional probability. So here's where we've been already. We've already talked about probability basics. We've talked about what events are and some of the rules, especially with events that are this or that kind of events. And then we talked about contingency tables last time, which included both joint and marginal probabilities. And so now we're going to be moving on to what's called conditional probabilities. So let's take a look at this first. Conditional probability the notation looks like this. It means the probability of event B happening, given that A has already happened. So this line right there means given. So we have two events, and we're taking the probability of event B happening given that A has already happened. We would read that the probability of B given A. So let's talk about what this will look like. So suppose we roll a dice, and we follow the following, we'd have the following sample space, so we could get a 1, 2, 3, 4, 5, or 6. We have two events. We're going to let F be that the event is that a 5 has been rolled, and O would be the event that the die comes up as an odd number. And so let's just take a look and see what these look like. First, the probability of F, the probability that a 5 is rolled is going to be 1 out of 6 different possibilities. So that's what A would look like. B is red, the probability of F given O. So the probability that we get a 5 given that it's odd. Well, there's a couple ways to do this, but if we know that we have an odd number, that means it's either going to be a 1, 3, or 5. So there's 3 possible answers for that, and only one of those 3 is a 5. And so the probability of F given O is 1/3. And then we can take a look at C, the probability of O given not F. So the given part is what our total is going to be. We know that it's not a 5. It's not this one. So that leaves 5 choices. And so what is the probability that it is odd given that we know it's not the 5? Well, it could be the 1 or it could be the 3. And that would be 2 out of 5. So that's what conditional probability looks like. There is a formula for it to help us out when it gets a little bit more complicated. And we're going to get into that here in a little bit. All right, conditional probabilities from a joint distribution table. And here's where it gets a little bit more challenging. We're going to use the table on the next slide to find the following probabilities. So the first one is the unconditional probability that a selected faculty member is in his or her 50s. So this is not a conditional probability. We just want to know what's the probability that this professor is, a given professor is in his or her 50s. So let's go to this slide real quick. If we look at this slide, here are all the people that are in their 50s, and that is a total of 253 of them out of 1,164. So to answer this question, we would take 253 out of 1,164 people. That's not a conditional probability because it's out of the total amount. That's different than in number 2, because number 2 is a conditional probability question. And the question is, what is the probability that a selected faculty member is in his or her 50s given that he or she is an assistant professor? So we know that they are an assistant professor. We know they're in this column here. And how many total people are in that column? Well, that's 320. And how many of them are in their 50s? That's 36. So it is going to be 36. Oops, wrong way. It is going to be 36 out of 320, whatever that is as a percent or whatever that is as a decimal. That's what the conditional probability is. The big thing is that the denominator is different. The denominator is not out of the total number of people. It's out of what is given. All right, so let's see what this rule is saying. It is saying that the probability of B given A can always be found by first finding the probability of B and A and dividing it by the probability of A. Notice the given, that's what it's out of. That's the denominator. Okay, so if I was going to go back and answer this probability, this number 2, this conditional probability question, using that formula, this is the way I would use that formula. We want to find the probability that a selected faculty member is in his or her 50s, given that she is an assistant professor. Well, the given that she is an assistant professor, that's this part right here. That's the 320. Okay, that's this right here. We have 320 total assistant professors. Well, what's the probability of A and B? Well, the probability of A and B is that this professor is in their 50s and they're an assistant professor. That's the joint probability, and that joint probability is 36. So we would have the 36 out of 320. And so that's how the formula works. That can kind of help us figure out what these conditional probabilities are. And so we can do a different one. Use the rule to calculate this probability. And so to calculate this probability, I don't know if this is the same one that we did. The R3, that's going to be in the denominator. So we're going to have R3 in the denominator. Let's do that part first. R3 in the table that we just did is the table that we're working with here. Okay, and R3 is 320. Yeah, it's the same one. So that's going to be 320. And then A4 and R3, well, if I go back, A4 and R3 is the 36 because it's in both. It's the joint probability that is in both of them. And so that would mean that we would have the 36 in the numerator. So this is what this question could look like. The same question as number 2 in the previous slide. All right, so let's take a look at this. We have marital status. So you're either single, married, widowed, or divorced, and you're either male or female. So this is a joint distribution table with your marital status and your gender. So let's say we want to determine the probability that the adult selected is divorced given that the selected is a male. So we could write it like this. So we're given that it's a male, that's S1. Okay, that's going to be in the denominator. So it's going to be 0.485. That's the denominator. And we want to know what's the probability that the adult selected is divorced. Well, that's M4. And so we're going to take the probability of both M4 and that you're a male. So that's this joint probability, which is 0.044, divided by the people that we're interested in, which is just the males, given that you're a male. That's the 0.485. And if we divide these two decimals, we're going to get the conditional probability that you are divorced given that you're a male. And then number 2, determine the probability that an adult selected is a male given that the adult selected is divorced. So we're just kind of switching these two around here. So now what's given is M4, given that you're divorced. So given that you're divorced, well, that's 0.104. 0.104. That's the denominator. And then we want to know what's the probability that you're a male given that you're divorced. So of those, how many of them are males? Well, that's this right here. So that's S1 and M4, which is the 0.044 divided by 0.104. So whatever this comes out to be, that's going to be the probability that you're a male given that you are divorced, using that table. This is what your homework will look like today in Math Excel, and that's really what 4.5 is about, and we will work on our homework and talk about it tomorrow in class. Good luck, everybody. See you tomorrow.